Hello everyone, this is a video for the section 10.1 notes, which is titled The Language of Hypothesis Testing. And as the title implies, this section here is a lot about the language, and so there's going to be very little to do in the way of calculations or something like that. It's mostly going to be talking about some new terminology, especially with these types of things about hypotheses, null hypothesis, alternative hypothesis, stuff like that, drawing conclusions. And in general, we are striving to synthesize a lot of what we've done before, especially in the way of using the calculator, to test a hypothesis. And this will have to do with critical values like we've seen before with the z values and the z alpha over 2, the z alpha, all of these kinds of critical z-scores and stuff like that. We will use those as our standard of whether to reject a null hypothesis or not. And so now that I've used unknown terminology, or it may be unknown to some of you who have not already completed the homework for this section, but we will start out just by talking about what a hypothesis is, which you know before from science classes, of course. And like I said kind of on the first day of this class or something, statistics really, and you may have noticed this yourself by now, it has a lot to do with a science class and whether it should be considered a math class or not. You know, obviously there's a lot of numbers in there, but we use so much that resembles a science class. It's kind of a little bit borderline, you know, kind of an opinion what you want to classify statistics as in the first place. But anyway, I digress, and we will talk about hypothesis, what it means in the context of statistics is that it will be a claim about a population. So instead of just a general hypothesis, which is something that's testable, right, by using an experiment, this will be a claim specifically about a population. So we can make a claim about a population proportion. We can say, you know, I believe that 10% of all M&Ms are green or something like that. Or else you can make a claim about a mean where you can say, I'm stating that the average height of 25-year-old males is 6 feet tall, something like that, or 5'9", or whatever the case may be. We will test these kinds of hypotheses. And so we will find a sample, of course. The way that we will test the hypothesis will be based on a sample. And we should know by now that samples are supposed to be random. They're supposed to be representative of a population, and that will allow us to use our sample to test claims. But of course, since we're testing these claims by using sample data, we've already seen before things about the sampling distribution of a sample mean, for example. It's possible to take a sample and say the population mean is here. It's possible to take a sample and the sample mean be something that's very unusual given the mean and standard deviation of the actual population. You can find unusual samples and stuff, so we may reject a hypothesis based on the sample that we found, but this could be incorrect, of course. It's basically an inherently faulty procedure by using sample, or at least not faulty, perhaps capable of being flawed or capable of making mistakes, of course. So in general, we will have quite a few components of a hypothesis test. We will talk about the first one right now, which is to actually state what the hypothesis is and what will be, for example, the null hypothesis, which null just means basically default. It could be interpreted that way, that we're talking about the default hypothesis, or it is at least the sort of a starting point where we are starting, what we're claiming to begin with, and then we're hoping to find a sample to be comfortable rejecting what our default value is for some type of a parameter. And in this case, the null hypothesis, we're writing capital H for hypothesis and then the little 0, because null also means 0. And that will always be the one, no matter whatever we're talking about, means or proportions, or whatever the case may be, the null hypothesis is always using the equal sign. And then the alternative hypothesis will use anything but an equal sign. It will also not use greater than or equal to, for example. Only greater than, we want to avoid the equals at all costs because that's already reserved for the null hypothesis. So we will say, for example, our null hypothesis can be that the proportion, which the population proportion, of course, is P, and we're using the population symbol here, the parameter. We can say that the proportion is 10% of all M&Ms are green M&Ms. And then we can test that perhaps something else is the case by taking a sample of M&Ms and counting how many of them are green. And then we should be clear, though, what our null hypothesis or what our alternative hypothesis is going to be in this case. We can test, for example, we're going to run an experiment by counting these M&Ms to find out whether the proportion actually is greater than 0.1. We suspect that there is a leprechaun who works in the M&M factory, and he's trying to skew the proportion so that there are more green M&Ms than anything else. And what we will talk about here, whenever we are using some more terminology to describe these kinds of tests that we're going to do, the tests, and here the tail, left tail, right tail, it has to do with the familiar meaning of tails in all of this statistics class, is whether, here's, for example, the population proportion. We are testing whether the sample value, whatever we come up with from the sample, is so many standard deviations away that we will be landing in this kind of, see, for example, we're testing whether the true proportion actually is greater. So if we get a sample that's inside of this sort of a right tail, in this case, because we're using greater, so if the true proportion is here, or at least this is the one that is belonging to the null hypothesis, then we want to find a value that's greater by being in this kind of a right tail. And the way we'll test it will have to do with some type of it's not going to be necessarily called the confidence level in this case, but it will have to do with that same alpha situation that we had from the confidence interval, where here, if we're using an alpha value of 0.05, then we will find the appropriate critical value such that this area is the amount of the alpha value, which is 0.05. And then if our test statistic, which is the proportion from our sample, is so many standard deviations above the null hypothesis value, then we will be able to reject the null hypothesis and say that, wow, it was an unusual sample. And so we will I don't want to use the word confirm. We will reject the null hypothesis in order to go for the alternative, which is that the proportion must actually be greater. This would be an example of a right-tailed test. A left-tailed test would be if we are testing whether something is less than something. So we're looking for some type of a critical value on the low end. And then a two-tailed test will be if we're testing whether something is not equal. So we're using sort of the not equal symbol. And in this case, we want to be a certain number of standard deviations either to the left or the right. That will give us the impression that the parameter is not equal to this, because it might be greater, it might be less, it might be on the right, it might be on the left. And we just want to disconfirm, as it were, that the value is equal to something. But we will see so many examples about this, and I don't want to get too complicated or too far ahead of myself right now. We are going to see a fully worked out example of testing a hypothesis, and it's going to be great. So stay